Now question number 31 is, let xy be points in A such that x square plus y to the power 4 is less than or equal to 1. And then B is x to the power 4 plus y to the power 6 is less than or equal to 1. Then we need to find whether B is a subset of A or A is a subset of B. Now what we'll do is we'll take any point P, which is x comma y in set A. So it simply means x square plus y to the power 4 is less than or equal to 1. Now since sum of squares or even powers is less than or equal to 1, we can say xy belongs to 0, 1. Now we'll find the value of x to the power 4 plus y to the power 6. So we know that x to the power 4 plus y to the power 6, we can write this as x square into x square plus y to the power 4 into y square. Now maximum value of x square or y square is 1. So that means this is always less than or equal to x square plus y to the power 4, and we know that x square plus y to the power 4 is always less than or equal to 1. So that means for any point P xy in A, that point it also belongs to B. So every point in A lies inside B. So it simply means that this A is a subset of B, and that's your option number B. Now question number 32 is, a square of side A and equilateral triangle of side B is inscribed in a circle, then A upon B is. So we have a circle whose radius is say R. Now if a square is inscribed in the circle, then this is A, this is A, this is diameter 2R. We can write A root 2 equals 2R. Then the value of A is root 2R. Now if an equilateral triangle is inscribed in this circle, now this is R and this angle is 30. Now this length is R cos 30. Now B is 2 times R cos 30. So we can write B as 2R cos 30, and cos 30 is root 3 by 2. So B is root 3R. Now we need to find the value of A upon B. So value of A upon B simply will be root 2 upon root 3, and that's your option number A. Now question number 33 is, if fx is a real valued function such that 2fx plus 3f minus x is equal to 15 minus 4x for every x belongs to R, then f2 is. Now basically this equation, it is a linear equation in fx and f minus x. Now we'll put x as 2, we'll get 2f2 plus 3f minus 2, and it'll be equal to 15 minus 8, and 15 minus 8 will be simply 7. Now in the same way, we'll put x as minus 2, we'll get 2f minus 2 plus 3f2, so it'll be 8 plus 15. Now 15 plus 8 is simply 23. Now we'll need to eliminate f minus 2. So we'll multiply this first equation with 2 and second equation with 3. And then we'll subtract first from second. So here it will cancel. Now here will be 9f2 minus 4f2. There'll be 5f2, and it'll be simply 23 into 3 minus 14, which is nothing but 55. That means value of f2 is simply 11, and that's your option number C. Now question number 34 is, if fx is root 3 sin x upon 2 plus cos x, we'll need to find a range of fx. Now what we'll do is we'll find f dash x. Now f dash x will be root 3. Now it'll be 2 plus cos x, and derivative of sin x is cos x minus sin x, and derivative of cos x is simply minus sin x upon 2 plus cos x whole square. So we can add this as root 3, and here it will be 2 cos x and then plus cos square theta plus sin square theta, which is 1 upon 2 plus cos x whole square. Now this function, it is continuous and differentiable function. So we'll find its critical points. We'll get cos x as minus 1 by 2. So cos x is minus 1 by 2 when the value of x is either 2 pi by 3 or 4 pi by 3. There are two roots, 2 pi by 3 and 4 pi by 3. So this is plus, minus and plus. So we'll get a local maxima at 2 pi by 3 and we'll get a local minima at 4 pi by 3. Now its maximum value will be when x is 2 pi by 3. Now we'll put x as 2 pi by 3, it'll be root 3. Now sine 2 pi by 3 is root 3 by 2 and this is 2, and then cos 2 pi by 3 is simply minus 1 by 2. So we'll get this as 3 by 2 upon 3 by 2. So maximum value is 1. In the same way we can find its minimum value. So it'll be root 3 and then minus root 3 by 2 and it'll be 2 minus 1 by 2. Again it'll be minus 1. Now this function is a continuous function. So we'll take all the values between maximum and minimum value. So the interval or the range of fx is from minus 1 to plus 1, and that's your option number C. Now question number 35 is, if fx is x square and gx is x sin x plus cos x, then f and g agree at how many points? So we need to find number of real solutions of this equation, which is x sin x plus cos x equals x square. So what we'll do is we'll take a function hx, which is x sin x plus cos x minus x square. Now we'll find h dash x, we'll get x cos x plus sin x minus sin x minus 2. Now here sin x will cancel. We'll get h dash x as x into cos x minus 2. So the only critical point in this case is at x equal to 0. Now rightmost it is minus and here it is plus. So this function, it will have a local maxima at x equal to 0. So this function, it starts from minus infinite. It'll take local maximum value at 0 and then this function again it'll go to minus infinite. We'll need to find value at 0. So what is the value of h0? h0 will be x sin 0 is 0, cos 0 is 1 and then 0. So value of h0 is 1. So this function, it attains its maximum value at 0 and the value is 1. So this function, it can be drawn like this. Now this function will intersect x-axis at 2 points. So that means f and g, they agree at exactly 2 points, and that's your option number C. Now question number 36 is, we are given this function fmn, we need to find the value of f11. Now if we'll put m as 1 and n as 1, we'll get f1 minus 1, it'll be f0 and f1 comma 0. Now when m is 0, we know that this is n plus 1. So that means this value is equal to f1 comma 0 plus 1. Now we'll need to find the value of f1 comma 0. So for this second one, we'll put m as 1 and n as 0. So we'll put m as 1 and n as 0. We'll get f0 comma 1. And when m is 0, it is n plus 1. So it'll be 1 plus 1, it is 2. So value of f11 will be simply 2 plus 1, and that is equal to 3. And that's our option number B. Now question number 37 is, if fx equals 0, then we'll need to find number of distinct real roots. Now what we'll do is, we'll first write r1 as r1 plus r2 plus r3 plus r4. So everywhere it will be x plus 3a. So we can take this x plus 3a common. We'll get x plus 3a and then it'll be 1, 1, 1, 1, a, x, a, x, a, and then a, and x, and this is equal to 0. Now what we'll do is, we'll write c1 as c1 minus c2, c2 as c2 minus c3, and c3 as c3 minus c4. So we can write this as x plus 3a, and here it'll be 0, a minus x, 0, 0, it'll be 0, x minus a minus x, 0, and then 0, 0, x minus a minus x, and will be 1, a, x, and it'll be 0. Now if we expand it about this first row, then we can write this as x plus 3a into a minus x whole cube equals to 0. So the value of x is either minus 3a or the value of x is a. Now if a is non-zero real, That means number of distinct real roots will be 2, and that's your option number B. Another way of solving the same question can be, we can write this matrix as matrix consisting of 4 blocks. This is A and this is B. So we can write this matrix Fx as A, B, BA. Now determinant of Fx, it will be determinant of A plus B into determinant of A minus B. And if it is 0, then either determinant of A plus B is 0 or determinant of A minus B is 0. Now we'll take A plus B. We can write this as x plus A, 2A, 2A, x plus A. Either it will be 0 or we'll write x minus A, 0, 0, x minus A will be 0. So from here we can write x plus A whole square minus 4A square is equal to 0. So A plus B, A minus B. So we'll get x plus 3A into x minus A as 0 or x minus A whole square equals to 0. So the value of x is again either minus 3A or the value of x is A. So again number of distinct real solutions is 2. So we can solve it using determinant properties or we can solve it using block matrices. Now question number 38 is, a real 2 cross 2 matrix M is such that M square is minus 1, 0, 0 and minus 1 minus epsilon, then which of the following option is true? So let us take this M as sum A, B, C, D. Now if we'll find M square will be A, B, C, D into A, B, C, D. Now we'll multiply it, we'll get A square plus BC and then BA plus D, and here it will be CA plus D and then BC plus D square. Now this value, it must be equal to minus 1, 0, 0 and minus 1 minus epsilon. Now we'll compare, we'll get condition which is A square plus BC is equal to minus 1, D square plus BC is equal to minus 1 and then B into A plus D is 0 or C into A plus D is 0. Now either B is 0 or A plus D is 0. Now we'll take B as 0, then in that case we'll get A square equals minus 1. So we'll not get any real solution. In the same way we'll take C as 0. Again for C equals 0, we'll get D square equals minus 1. So again we won't get any real values of A, B, C, D. So that means the only condition that we have here is value of A plus D must be 0. That is value of A is equal to minus D. Now if value of A is equal to minus D, then A square plus BC must be equal to D square plus BC. Now A square plus BC is minus 1 and D square plus BC is minus 1 minus epsilon. So that means from here we'll get this condition as minus 1 minus epsilon must be equal to minus 1. That is value of epsilon must be 0. This is true only when value of epsilon is 0. So this real matrix does not exist for any epsilon greater than 0, and that's your option number B. Now question number 39 is, we need to find eigenvalues of this matrix. So we can write characteristic equation as 2 minus x, 2 minus x, 2 minus x, and it will be 1, 1, 1, 1, 1 and 1, and it should be equal to 0. Now what we'll do is we'll write R1 as R1 plus R2 plus R3. So we'll get 4 minus x. So we'll take 4 minus x common. Then we'll get 1, 1, 1, 1, 2 minus x1, and then 1, 1, 2 minus x, and it is equal to 0. Now we'll write C1 as C1 minus C2 and C2 as C2 minus C3. So we can write 4 minus x and it will be 0. And then 1 minus 2 plus x. So it will be minus 1 plus x. And here it will be 0. Here it is 0. And then 1 minus x. And here it will be minus 1 plus x. And it will be 1, 1. And 2 minus x. It is equal to 0. So if we'll expand it about this one, we'll get 4 minus x into x minus 1 whole square equals to 0. So the eigenvalues are 1, 1 and 4, and that's your option number A. Now question number 40 is, let x1, x2, x3, x4 and y1, y2, y3 and y4 be fixed real numbers, not all of them equal to 0. Then define a 4 cross 4 matrix A this way. Now we can actually write this matrix A as a product of two matrices. We can write this as x1, y1, 0, 0, x2, y2, 0, 0, x3, y3, 0, 0, and x4, y4, 0, 0, and multiplied with x1, y1, 0, 0, x2, y2, 0, 0, x3, y3, 0, 0, and x4, y4, 0, 0. Now we have expressed A as product of two matrices P and Q. Now rank of P is less than equal to 2, and in the same way rank of Q is also less than or equal to 2. Now we know that if A is equal to PQ, then rank of A, which is rank of P into Q, is less than equal to minimum of rank of P and rank of Q, which is 2. So that means rank of A is always less than equal to 2. So that means rank of A can be either 1 or 2, and that's your option number A. Now question number 41 is, let K and N be integers greater than 1, then factorial K into N is not necessarily divisible by. Now we know that we can write this as 1, 2, 3 up to K into N. Now there are Kn numbers, so we can divide these numbers as either K groups each containing N or N groups each containing K elements. Now we also know that product of any consecutive N numbers is divisible by factorial N. Now if we consider K groups each containing N elements, then each group is divisible by factorial N. So that means this expression will be divisible by factorial N to the power K. In the same way, if we consider it as N groups containing K elements, K consecutive elements each, then it will be divisible by factorial K to the power N. Factorial N and factorial K, it is a trivial case, so it has to be this option D, which is 2 to the power Kn. We can also take up an example. Suppose K is 2 and N is 2, then factorial Kn is factorial 4, which is 24, and it is not divisible by 2 to the power 4, which is 16. So 16 doesn't divide 24. So this expression is not necessarily divisible by this expression D, which is 2 to the power Kn. Now question number 42 is, if lambda 1, lambda 2 and lambda 3 are eigenvalues of this matrix and their sum is root 2 plus 1, we need to find possible values of T. Now we know that sum of eigenvalues is equal to trace of this matrix. So if we'll write trace, it will be 1 plus 2 cos T, and it is equal to root 2 plus 1. So value of cos T is equal to 1 upon root 2. Now in this interval, this T can be either minus pi by 4 or plus pi by 4, and that's your option number C. Now question number 43 is, the value of eta for which the following system of equation has a solution. Now we'll find delta for this system of equation. It will be 1, 1, 1, 1, 2, 4 and 1, 4, 10. This delta is 0. So that means this equation can have either no solution or infinitely many solutions. Now in this case, it should have infinitely many solutions. So you'll have infinitely many solutions when each of delta I is 0. Now we'll find delta 3, we can write this as 1, 1, 1, 1, 2 eta and 1, 4 eta square, and it is equal to 0. Now we'll write C3 minus C2 and C2 minus C1. So it'll be 0, n minus 2, n square minus 4, it'll be 0, 1 and 3, it'll be 1, 1, 1, and it'll be equal to 0. We can take n minus 2 common. So we'll take n minus 2 common, and if we'll expand, we'll get n plus 2 minus 3 equals 0. So the value of eta is either 1 or 2, and that's your option number D. Question number 44 is, let P1, P2 and P3 respectively are the planes determined by these three linear equations. Now it is given that these three planes, they intersect exactly at one point. Now we know that these three planes, they'll intersect at one point when the system of equation will have unique solution, and it will have unique solution, value of delta is unequal to 0. So this determinant, which is a1, b1, c1, a2, b2, c2, and a3, b3, c3, value of this determinant is unequal to 0. Now I will put alpha 1 as 1, alpha 2 as 1, and alpha 3 as 1. It doesn't change this determinant. This determinant will still be delta unequal to 0. And when it is delta unequal to 0, it simply means that these linear equation will have a unique solution. So which again says these planes, they'll intersect at a unique point, and that's your option number B. Number 45 is angle between any pair of four main diagonals of a cube R. So if we consider a cube, now this is origin. Suppose this point is 1, 0, 0. It is 0, 1, 0. It will be 0, 0, 1. This point is 1, 0, 1. This is 1, 1, 0. It will be 0, 1, 1. And then this point will be 1, 1, and 1. Now we'll find direction ratios of diagonals of a cube. So we know that direction ratios of diagonals of cube are 1, 1, 1, minus 1, 1, 1, 1, minus 1, 1, and 1, 1, and minus 1. Now we'll find angle between any two diagonal. It'll be cos theta and then minus 1 plus 1 plus 1 upon root 3. So it'll be simply 1 by 3. So angle will be cos inverse 1 by 3, or its supplementary angle, which is pi minus cos inverse 1 by 3. So angle between any four pairs will be cos inverse 1 by 3 or pi minus cos inverse 1 by 3, and that's your option number B. Now question number 46 is, if the tangent at P with coordinates h comma k on this curve y square equals 2x cube is perpendicular to this straight line, then we need to find the value of h and k. Now since this point, it lies on this curve, we can write k square and it is equal to 2h cube, and that's our first equation. Now we'll differentiate, we'll get 2y dy by dx, and it'll be equal to 6x square. So dy by dx at this point P, it will be 3h square upon k. Now this tangent, it is perpendicular to this straight line. So product of slope is minus 1. So we'll get 3h square upon k into 4 upon 3, and it is equal to minus 1. This 3 will cancel. We can write the value of k as minus 4h square. Now we'll put the value of k in this first equation. We'll get 16h to the power 4 is equal to 2h cube. That is, the value of h is 0, or the value of h is 1 by 8. Now if h is 0, we'll get k as 0. And if h is 1 by 8, we'll get value of k as minus 4 and 64. It'll be minus 1 by 16. So it'll be this option C, that is either 0, 0 or 1 by 8, minus 1 by 16. Now question number 47 is, consider a family of curves in the plane given by x equals cy square. Now we need to find orthogonal trajectory for this curve. Now for orthogonal trajectory, first we'll find differential equation for this given family. So we'll differentiate, we'll get 1, and this is c, and it'll be 2y into y dash. Now we'll eliminate this c, we can write x, and this c will be 1 upon 2y into y dash, and it is equal to y square. Y and y will cancel. We'll get y dash as y upon 2x. For orthogonal trajectory, tangent of this given family will be normal to this other family. So that means we'll replace dy by dx with minus dx upon dy. So we'll get minus dx upon dy, and it is equal to y upon 2x. So it'll be 2x dx plus y dy equals 0. Now we'll integrate, we'll get x square plus y square upon 2 equals c. So this equation will be 2x square plus y square equals 2c, which is some constant, say k square, and that's your option number C. Now question number 48 is, suppose a circle x square plus y square plus 2fx plus 2gy plus c equals 0 cuts the parabola y square equals 4ax at 4 distinct points. So we have a circle and a parabola, and they intersect at 4 distinct points. Now we know that any point on this parabola, we can write this as at square, 280. Now for point of intersection, this point, it will also lie on this circle. So we'll put the value of x and y. We'll get a square t to the power 4 plus 4a square t square plus 2f at square plus 2g 2at plus c equals 0. So we can write this equation as a square t to the power 4 plus 4a square plus 2af t square plus 4agt plus c equals 0. Now since there are 4 points of intersections, this equation will have 4 real roots. Say t1, t2, t3 and t4. Now we'll write S1. S1 will be t1 plus t2 plus t3 plus t4 and it will be equal to coefficient of t cube. Now there is no coefficient of t cube. No coefficient of t cube. That means t1 plus t2 plus t3 plus t4 is simply 0. Now we need to find sum of ordinates. Now sum of ordinates is summation 2a ti. So it will be 2a and then t1 plus t2 plus t3 plus t4. Now this is nothing but 0. So sum of all these ordinates will be 0 and that's your option number A. Now question number 49 is the polar equation r equals a cos theta. It represents what? So what we'll do is we'll multiply it with r. So it'll be r square and then a r cos theta. Now r square is x square plus y square and a r cos theta is x. So we'll get this equation as x square plus y square minus ax equals to 0, which is nothing but a circle. So answer is a circle, which is option number C. Now question number 50 is we are given v1, v2 and v3 and we need to find which of the following is true. So what we'll do is we'll write vn plus 1 and we'll write vn plus 1 as 7 minus n square plus 8 square plus 15 square plus 23 plus n whole square upon 4 and here it will be 7 minus n plus 8 plus 15 plus 23 minus n upon 4 whole square. Here n and n will cancel. So we'll write this vn plus 1 as 49 plus n square minus 14n plus 8 square plus 15 square plus 23 square plus n square plus 46n upon 4 and minus 8 plus 15 plus 7 plus 23 upon 4 whole square. Now here minus 14n and plus 46n will be plus 32n. So we can write vn plus 1 as n square plus 32n plus 7 square plus 8 square plus 15 square plus 23 square plus n square. So it will be 2n square upon 4 minus 8 plus 15 plus 7 plus 23 upon 4 whole square. Now this is an increasing function in n. As the value of n increases, the value of vn plus 1 increases. So it simply means that v1 is less than v2 is less than v3 and that's your option number C. Now question number 51 is the permutation of 1, 2 up to n is chosen at random. We need to find the probability that numbers 1 and 2 they appear as neighbors. Now total number of ways in which we can arrange these n numbers is factorial n. Now if 1 and 2 they appear as neighbors, then we'll use string method. So we'll tie them up. So now we have n minus 1 objects. We can arrange these n minus 1 objects in factorial n minus 1 ways, and then these two they can be arranged among themselves in factorial 2 ways. So it will be simply 2 by n. So this probability is simply 2 by n and that's your option number B. Now question number 52 is two coins are tossed independently where probability head occurs when coin I is tossed is Pi. It is given that at least one head has occurred. What is the probability that coin produced different outcomes? So we need to find this probability that it produced different outcomes when we know that at least one of them is a heads. Now when we say at least one of them is a heads, it will be probability of H1 plus probability of H2 minus probability of H1 intersection H2. Now, what is the probability that the coin produced different outcomes when at least one head has occurred? So either it could be first is heads and second is tails, or first is tails and second is heads. Now these probabilities, they are independent. So we can write probability of H1 as P1, and then probability of second tails is 1 minus P2, and in the same way it is 1 minus P1, and it will be simply P2 upon this is P1 plus P2, and then P intersection B is P into PB. So it will be P1 into P2. So we can write this as P1 plus P2 minus 2 P1 P2 upon P1 plus P2 minus P1 P2, and that's your option number B. Now question number 53 is the number of cars X arriving at a service station per day follows a Poisson's distribution with mean 4. So value of lambda is 4. Now it says the service station can provide service to a maximum of 4 cars per day. Then the expected number of cars that do not get service per day equals what? Now what we'll do is we'll define a random variable X equals I, and then we'll find its corresponding probability Pxi. And then we'll also define a random variable XR, which represents number of returned cars. If I is 0, then XR is 0. If I is 1, then again it is 0. So if it is 0, 1, 2, 3, 4, then number of returned car will be simply 0. But when we have more than 4 cars, now 1 will be returned, for 6 it will be 2, for 7 it will be 3, and then we have their corresponding probabilities, which are probability X equals 5, probability X equals 6, probability X equals 7. So we can write expected number of returned car will be 0 into Px equal to 4 plus 1 into Px equals 5 plus 2 into probability X equals 6, and it goes up to infinite, which we can write as I into P X equals I plus 4, where the value of I varies from 0 to infinite, and that's your option number C. Now question number 54 is if X lies between 0 and 1, we need to find sum of this infinite series. Now we can write this 1 by 2 as 1 minus 1 by 2 into X square, and we can write 2 by 3 as 1 minus 1 by 3 into X cube, 1 minus 1 by 4 into X to the power 4, and this series that continues up to infinite, we can write this as X square plus X cube plus X to the power 4, and then minus X square by 2 plus X cube by 3, and this series also continues up to infinite. What we'll also do is we'll add X and we'll subtract X. We'll write X plus X square plus X cube, and then here will be minus X square upon 2 minus X cube upon 3 up to infinite. Now this is nothing but an infinite GP, so it is A upon 1 minus R, and this second series, it is nothing but it is series expansion of log 1 minus X. So answer to this question will be X upon 1 minus X plus log 1 minus X, and that's your option number D. Now question number 55 is let an be a sequence of real numbers, then limit n tends to infinite an exists if and only if. Now which of the following option is correct? Now what we'll do is we'll say suppose this limit n tends to infinite a to n, it is say L1, limit n tends to infinite a 2n plus 1, it is suppose L2, and this limit n tends to infinite a 3n, and suppose this is L3. Now we consider this sequence, which is a 6n, then a6n is a subsequence of a2n because it is a multiple of 2n. So we know that any subsequence will converge to the same limit. So this subsequence, it will converge to L1. Now 6n is also a multiple of 3n. So that means this 6n is again a subsequence of A3n. So that means it will converge to L3. So from here we can say L1 must be equal to L3. Now let us consider another sequence which is A6n plus 3. Now A6n plus 3, it is subsequence of A3n. So that means it will converge to L3. And we can also write A6n plus 3 as 2 into 3n plus 1 plus 1, which is of the form 2n plus 1. So that means it is a subsequence of A2n plus 1. It also converges to L2. So from here we can say L3 must be equal to L2. So L1 must be equal to L2 must be equal to L3. Now L1 is equal to L2. So that means from here we can say these both A2n and A2n plus 1, they converge to same limit. So that means this limit n tends to infinite. It also converges to the same limit. So answer to this question is option number C. Now question number 56 is, if A and B is sequence of non-negative real numbers such that the series n varies from 1 to infinite, an is convergent if P is a real number such that this series summation under root an upon n to the power P diverges, then which of the following is true? Now from Cauchy-Schwarz inequality we can say that this summation under root an upon n to the power P, it is less than or equal to summation an whole to the power 1 by 2 and this summation 1 upon n to the power 2p to the power 1 by 2. Now it is given that this series diverges and summation an, it is a convergent sequence. So that means this sequence which is summation 1 upon n to the power 2b, it must be a divergent sequence. Now we know that this sequence diverges when the value of 2p is less than or equal to 1. That is, the value of p should be less than or equal to 1 by 2. And that's your option number B. Now question number 57 is, consider the sequence an and it is ea to the power 1 by n minus a to the power 1 by n upon 1 by n. Now we need to find this limit, which is limit n tends to infinite an. So we can write this as limit n tends to infinite and then ea to the power 1 upon n minus a to the power 1 upon n upon 1 by n. Now what we'll do is we'll let 1 upon n as t, then we can write this limit as limit t tends to 0 ea to the power t minus a to the power t upon t. Now this is 0 upon 0 form. So we can use L'Hopital's rule. So we can write limit t tends to 0 ea to the power t into log ea minus a to the power t into log a. Now we'll put t as 0. So we'll get this as log ea minus log a. So it'll be simply ln e, and ln e is nothing but 1. So answer to this limit is 1, which is none of the above, option number D. Now question number 58 is, let a and b a sequence of real numbers satisfying mod an is less than or equal to 1 for all n. We define an as 1 by n a1 plus a2 plus an. Then for n greater than or equal to 1, we need to find this limit n tends to infinite under root n an plus 1 minus an. Now we look at this limit, we can write this as limit n tends to infinite. Now under root n, now what is an plus 1? It is nothing but it is 1 upon n plus 1 a1 plus a2 plus an plus an plus 1 minus 1 upon n a1 plus a2 plus an. Now we'll take LCM, we can write this as limit n tends to infinite under root n. Now LCM will be n plus 1 into n, and here will be n a1, n a2 and n an plus 1. So here we'll get n a n plus 1. Now n a1 minus n plus 1 a1. So it'll be minus a1 minus a2 and minus an. Now we know that for any an, its modulus is always less than or equal to 1. So we can say this limit is less than or equal to limit n tends to infinite under root n upon n plus 1 into n, and here we can write this as n mod an plus 1 plus mod a1 plus mod a2 plus mod an. Now maximum value of any an is 1, so we can write this is less than or equal to limit n tends to infinite, and this is under root n. Now this is n, and then maximum value for each is 1, so it will be 1 plus 1 plus 1 up to n upon n plus 1 into n. So we can write this as limit n tends to infinite under root n into 2n upon n plus 1 into n. This n will cancel. Now power in the numerator is less than power in the denominator, so that means this limit will be 0. So from here we can say that this limit, it must be equal to 0, and that's your option number A. Now question number 59 is, in the Taylor's expansion of this function fx equals e to the power x by 2 about x equals 3, the coefficient of x minus 3 to the power 5 is. So we know that coefficient of any x minus a to the power n is fna upon factorial n. So coefficient of x minus 3 to the power 5 will be f53 upon factorial 5. Now I will differentiate this function 5 times, then f5x will be e to the power x by 2, and then every time we'll get 1 by 2. So it will be simply 1 by 2 to the power 5. So this expression will be e to the power 3 by 2 into 1 by 2 to the power 5 upon factorial 5, and that's your option number B. Now question number 60 is, let sigma be the given permutation and I be the identity permutation and m be the order of sigma. That is, m is minimum of positive integer n such that sigma to the power n is equal to I. Now first thing that we need to find in this question is disjoint cycles. Now 1, it is related to 3, 3 is related to 6, 6 is related to 9, and 9 is related to 1. So we have this one cycle which has 1, 3, 6 and 9. Now we look at another one which is 2, 5 and 5, 4 and 4, 2. So another cycle is 2, 4 and 5. And then we have 7, 8 and 8, 7. So it will be simply 8, 7. So we have 3 disjoint cycles in this permutation. Now order of this cycle is 4. This is 3 and this is 2. So order of this permutation will be LCM of 4, 3 and 2. So LCM of this number is nothing but 12. So value of m should be 12, and that's your option number B.